Good morning, geometry class. It's time for 11.7, the last lesson of the year. So as we're moving forward, we're going to be talking about something called the golden rectangle. Often in famous architecture, famous artwork, you will see the golden rectangle in play. It's something that's aesthetically pleasing to the eyes. That means when you look at it, it's supposed to be drawing your attention. And often when you look at things like television today, when a company will make a television, they want to frame something in the proportions of the golden rectangle. The golden rectangle is approximately a proportion that is approximately 1.6. Any place really around 1.6. And we'll talk a little bit more specifically as we move through the next couple of slides on how specific the golden rectangle, the golden proportion is. Okay, and when it comes time for the test, you're going to need to know and be familiar with the golden rectangle and how that works. So here we have a golden rectangle. This is like the basics in understanding how a golden rectangle works. What happens is if we have a rectangle that is 21 by 13. So what I'm talking about first, I want to explain this to you, is that the rectangle that I'm talking about is this guy right here, this yellow rectangle, 21 by 13, is a golden rectangle. So now if we take out and we say the golden proportion associated with that golden rectangle is 21 over 13. So I get out my handy dandy calculator and I say 21 divided by 13 is approximately 1.615. And I said anything that's really close to 1.6 is going to give you a golden rectangle. Now what I've done here in this diagram is I said, okay, let's cut out a square from this golden rectangle that is 13 by 13 by 13. So all sides are 13. So what I've done, again, I'm going to explain this, is I've cut out a square out of the golden rectangle. And so then what happens if you take 21 minus 13, you're left with 8. So you see 8. And this side is still 13. So you got a triangle, or a rectangle, not a triangle, that is 13 by 8. So I'm going to get out a highlighter. I'm going to show you what I'm talking about. 13 by 8 is the rectangle that's left when I cut out a square. So I took the 13 by 13 square and I said, okay, let's cut that out. What should be left, that blue rectangle, it should be another, if what I started with was a golden rectangle, what should be left should be a golden rectangle. So it's 13 divided by 8, which if I take out my handy dandy calculator and I do 13 divided by 8, I get 1.625. 1.625. And you can see that's approximately 1.6, 1.6. Now, what would happen if I cut out another square? So if I took like a square out of this, and I'm sure these dimensions aren't perfect, but let's say we took out a square again, that would end up like this. So if this was 8, this would be 8 and 8 and 8. That would be a square in there. So then, what would be left? And I'm going to get out a green highlighter here. I'm going to say, what would this be left? And again, it kind of looks kind of funny, but we're going to pretend that it looks closer to a square than the actual square that I started with. But what would be 8 left? So if I started with 13 as my side, and I subtracted out that square of 8, then what would the dimensions be over here? Wouldn't this side be 8 and 8, but this would be 13 minus 8, which would be 5. So now I got 5 by 8, a rectangle that's 5 by 8. So let's see what happens when we take our 8 by 5. And we do that on our handy dandy calculator. So we do 8 divided by 5 gives me exactly 1.6. Another golden rectangle. Well, could I do that again? Like if I said like, okay, let's take this and let's cut out a square that's 5, 5, 5, 5. What would be left? So the green line here was 8, and I cut out a 5. Wouldn't that be 3? So then we'd have a rectangle, this black rectangle right here that I'm filling in. That would be 5 by 3. So if we do 5 divided by 3, 5 divided by 3 is approximately 1.6 repeating. Okay, and the idea is you could keep going and keep going and keep going, and you'd always have this aesthetically looking rectangle that would come by cutting out a square, cutting out a square, cutting out a square, cutting out a square. Okay, so we get to the next slide, and it says there actually is an actual golden ratio, and it's 1.1 plus the square root of 5 divided by 2. So if I took out my calculator, and you could try this, you do the square root of 5, you find that to be 2.236. So you do 1 plus approximately the square root of 5 is 2.2360678. I could keep going and keep going. Divide that by 2. So I'm going to take that 2.23 and I'm going to add 1. So I get 3.2360678. And I'm going to divide that by 2. Let's see what happens. When I divide it by 2, I get approximately 1.6180. And this is the K factor of the golden ratio. That's an approximation. This is the exact golden ratio, and this is the K factor of the golden ratio. Now, when it comes to the test, that's coming up, there are certain terms that you need to be familiar with. And one of them is golden ratio. So when it says golden ratio, this is what you want. This is a golden rectangle. Do you see the difference? This shape right here is a golden rectangle. This is the golden ratio. Ratio, another word for ratio that's going to help you on the test is the word fraction. The fraction that gives you 1.6180, the actual value of the golden ratio. So let me ask you this. If we were to look back here on this slide, I got 1.615, 1.625, 1.6, and 1.6. Which one of these is the best or closest to the golden ratio of 1.618? I'd say it's 21 over 13, wouldn't you? Okay, that's the one that's closest to that golden ratio. It's like 3/1000ths off. Okay, all the others fit the criteria. They fit within the leeway. You got to be within a couple 1/100ths of the golden ratio. Okay, so again, that K value 1.618. I want to know, is this a golden ratio? I got a golden rectangle. Is this a golden rectangle that forms a golden ratio? I see here it says that it's 2.6 long and 1.6 wide. So I'm going to take 2.6 by 1.6. So I'm going to do 2.6 divided by 1.6, and I get 1.625. And I'm going to give you a leeway of saying between 1.64 and 1.60. Anything in there will be a golden ratio, a true golden rectangle. So if we look back here, if I got to like the 5 by 3, according to the standard that I just set, that one doesn't meet the golden rectangle standard that I just gave you. But I'd say that does carry on, and that'd be close in the long run. You'd say, okay, we're diverging from a real golden rectangle, but for that purpose, I'd say that was pretty close. But it technically wasn't a golden rectangle. This is because it fits this criteria. This is the range for your golden rectangles. Okay, let's move forward. So what's the scale factor between these two? If this is the pre-image and this is the image, I think this is kind of like I want to look because I made this slide 2 years ago, so I just want to see if this fits for today's homework or if this is review for your test. I believe this is review for your test. This would be a K factor of 3. If this is the pre-image and this is the image, you'd take image over pre-image, 6 divided by 2 equals 3. And that's your K factor. All right? How about this one? If you go from a pre-image of 8 to an image of 1.6, in order to find the K factor, we do 1.6 divided by 8. 1.6 divided by 8 is 1.6 divided by 8 is 0.2. So the K factor would equal 0.2, or another way of looking at it is K equals 1/5 as a fraction or as a decimal. Let's keep going. Oh, that should be it. Homework I got for you tonight is 1 to 6 and 11 to 16. I didn't have a lot for you to begin with anyways tonight. If I shrink this, it's not going to leave you very much. Let's go with 1 to 6, right? And 11 and 12. 1 to 6 and 11 and 12 for your homework tonight. All right. I will be looking forward to getting your homework. Almost the end of the year. Have a great day.